What do you see as the biggest hurdles teams are facing when they're adopting AI agents?
So a lot of these AI initiatives actually fail. The pilot projects fail because the success criteria is too broad. We're able to design a system or a series of agents around a very, very specific, discrete problem. And we're able to measure the output of what we're getting to know if we're being successful or not. So that level of specificity has been very helpful for us to determine whether these are helpful or not, essentially, like in the process.
How do you see AI agents reshaping the space of software development and enterprise operations?
I think we're going to see a significant increase in productivity. It's going to be a combination of what I call like interface and operators. And I think you'll see like remarkable progress over the next couple of years, but it's going to be work, and it's going to take people like really digging into this and figuring out the best way to apply the technology.
Welcome to Tech Transformed, the podcast exploring the people and technologies shaping enterprise tech today. My name is Christina Stathopoulos, and I will be your host. After building out an advanced analytics career in big tech, I am now the founder of Dare to Data, on a mission to help individuals and corporations take the next step in their data and AI journey. In today's episode, I have the pleasure of speaking to Ben Gilman, CEO of Dualboot Partners. Together, we're going to explore AI agents, what they are, how they differ from traditional automation, how organizations are adopting them internally and with clients, and also how to ensure their use is both responsible and effective. So Ben, welcome to the show. It's great to have you on. Before we dig into this timely topic of AI agents, could you introduce yourself? Tell us a little bit about what you and your team do at Dualboot Partners.
Thanks, Christina. It's great to be here. At Dualboot Partners, we build custom digital technology solutions that range from marketing solutions to software and product solutions to data solutions. We're heavy into AI, and we're really excited about the power of this transformational technology. Excited to be here today to talk to you about it.
Perfect. We're excited to have you on the show. I know you've got a lot to share on this topic, so let's get right into it. Let's start right at the beginning. What exactly is an AI agent, and how is it different from a standard automation tool that teams might already be using?
So the biggest difference with an AI agent between a standard tool is that the agent is able to both perceive information, typically in like natural language processing, and it's able to think or reason about that. So it provides some level of context and outside information and consideration that you don't normally get in like what you might consider an algorithm. It presents some challenges, though. So now, rather than having deterministic systems, you have probabilistic systems. And so you have to accept that these agents, while they will think, the power of the thinking also brings risk with it, which is like it can do things that is unexpected. And so the best way we think about it at Dualboot is we think of these agents as team members. And just like members of your teams can think autonomously and make their own decisions and choose their own paths, these agents can do that as well. And so we think about that as we integrate them into the processes that we use inside the company.
Yeah, and I like how you added that element about deterministic versus probabilistic, because this is something I talk about as well a lot in my AI strategy trainings. Could you explain for the audience, just in case they don't know the difference, but what's the difference between that? And I also like, by the way, that you compare it to that, because you said these AI agents are like, they're probabilistic, they're like team members. And just like a team member, team members also have this uncertainty behind them, right?
That's right. So deterministic means essentially that 1 + 1 is always 2. Every time you run that algorithm, you will always get 2. Probabilistic means that 1 + 1 is 2 most of the time. And every once in a while, like 1 + 1 might not be 2. And in lots of situations, that's okay. But if you're working in highly regulated industries, or you're working with satellites or space travel or something that needs an extremely high degree of accuracy, probabilistic systems can be very problematic. And it also creates a problem just because it's a difference in strategy from how we've typically built software for the last 40 to 50 years, where all systems were deterministic. And now we're moving to this probabilistic era where we have to update how we're handling testing and validations and essentially operate with a margin of error that was something that's new for the entire industry.
That's a perfect explanation. And also, I think everybody can understand now a little bit more about what AI agents are. and also how they're differing from these traditional automation tools. So I want to talk about how this plays out in the real world. So how are AI agents actually being deployed in practice today? Do you have any real world examples you can share of how your clients are using them?
Yeah, so we've built a number of different AI agents. A couple examples of these is we built a virtual vet AI agent. So we had a company who had hundreds and hundreds of blog posts about animals, dogs, cats, and we took these blog posts and essentially used them as the primary or domain data set to drive a veterinarian agent. And so you could come in and you could ask the agent, my dog ate chocolate. What do I do? And it would provide an answer and say, well, chocolate's bad for dogs. You should call your veterinarian, or you should do these X, Y, and Z. And it would provide a list of articles that explain why, or the reasoning behind that information. We've also done work with data analytics, so allowing people to ask questions of their data in natural language form. And this was interesting because we actually did this without giving the agents access to the data. We simply gave it access to the structure of the data, and it was able to form queries to then query the structured data without passing any of this data to the LLMs that would allow us to return answers to the questions that they asked. And then internally, we use it a lot for coding. There's several good coding tools out there like Cursor and Copilot that really accelerate developers and developer productivity. We also use it to accelerate business and analytics. So many of our customers ask us to do modernization projects. So they help us move to the cloud, or we have an old COBOL application we need to move to something more modern. Some of the troubles with these programs is that nobody knows what they do anymore. Like all the people who wrote them left the companies. And so when we step in and we say, what do you guys want to do? How long is this going to take to do? We say, well, really, we didn't really know. And so we built our own custom agents that could essentially interrogate other people's legacy code bases and give us a pretty good idea of what those code bases were doing and what we would need to do in order to rewrite that information. That's interesting because for us, it expands the addressable market. We now took projects that we're unable to actually execute on because the cost of just figuring out what you needed to do to fix them was outside the bounds of the investment criteria. And with these agents, we can now do that in a matter of days instead of weeks to months. And so we're able to address problems that our clients have, as well as expand our own addressable market by tackling these programs and projects that typically would have been unaccessible.
Okay. I have a dog, so I love the first example of the vet. But I know that your specialty is software development. You were speaking about that this last example. It makes a lot of sense. It's very helpful. When it comes to the software development lifecycle, where do you think AI agents have the biggest impact? How are they changing the way that you see teams approaching how they build, how they test, how they maintain their software?
We've taken a very holistic and AI first approach to how we're addressing the SDLC process. In general, all of the team members who used to be individual contributors now are becoming more like managers. And each of them is paired with a single or potentially multiple AI agents that accelerate some of the, quote, busy work that they typically did before. These would be things like writing code, generating designs, business analytics. So digging through source code in order to figure out what something does. And so each of these team members, which is now more like an operator, right? They're kind of managing an AI agent or a team of AI agents. They're empowered to go faster, basically. And so our goal is really to increase productivity across the board. That generally leads to faster, cheaper projects, or more complexity, more scope inside of the same budgets.
I've heard it referred to as an AI orchestrator. I don't know if you've heard that before, but I really like that, an AI orchestrator. So each of these employees is really becoming, instead of an individual contributor, like you said, they're an orchestrator of AI agents, right? And they're increasing their productivity, what they're able to do with all of these extra team members working with them, right?
That's right. We used to call it that probably 12 or 18 months ago before they came up with the term agentic AI, which is sort of the industry standard term now that we use for the orchestration process.
Got it. And I know that from our previous conversations, you mentioned to me something about this DB90 methodology that you have at Dualboot Partners. Can you explain that a bit more? Because I think it will be relevant for our audience. Tell us a little bit about what is it, why does it matter in the context of software development?
Yeah, so DB90 is a methodology that we created that connects the people, the processes, and the AI tools like in the SDLC to speed up delivery, align the teams, and really like drive ROI. So while we talked about before, like each of these operators now or orchestrators has AI agents that they're working with. So they have their own little team. These teams and these agents don't work very well together. So you have a agent that sits in your requirements phase. You have different agents and tools that sit in your design phase. You have, again, different agents and tools that sit in the development phase. And these tools don't really work together. So we've had the invention now of like the MCP, so the Model Context Protocol, which allows the tools and the agents to interface like a little bit. And like while that gives us the technical means to actually like connect these tools together and make some like digital connections, there's still a lot of work that goes into like how do we actually move from requirements to design to development to test and ultimately to deployment. Like while we have these tools that are less flexible than team members used to be, right? So these tools are designed to do very specific things. And whereas we used to be able to just say team members and be like, hey, design and development, you guys need to work together. And like that was kind of the management layer that happened on top of it. And we kind of hoped that it would work. Now we have very specific tools that are doing specific things. And those interfaces aren't necessarily designed to work together. And so the DB90 methodology is really our methodology for how we get all of these systems to like talk to each other so that rather than having a series of siloed tools and experts, you actually have a full like system that works together that delivers like ROI. Otherwise, what we end up in is like we get really fast in each of the silos and then we spend all of our time trying to like integrate those silos together. And so without like having some sort of methodology around how do you do that integration, we don't see the productivity gains that you'd want to see.
Okay. And I want to focus on one point just to rewind back a little bit in case our listeners are unfamiliar with it or unaware of MCPs. You mentioned that, the model context protocols. Can we rewind back just to explain what exactly is in model context protocol? You hinted at it as well, and how it plays into this whole methodology that you're talking about, because it does help, but like you said, it's not enough, right?
So model context protocol is a way for an AI agent to connect to another tool. So the tool essentially publishes a list of things that it can do. An agent can then look at this published list of things it can do and decide which of those things are interesting to it. So it may be a thing like, so in our tool, for example, we have an internal tool called 3PO that helps us do requirements analytics. And what it does is our tool can publish like a list of domains, a list of use cases and user stories and things like that. So that when you're operating inside of Cursor and Cursor says like, oh, I need to like complete some task, it can then go ask the 3PO tool, which is like our requirements analytics, right? So it says, oh, give me the use case that I need for this specific task that I'm trying to implement. And 3PO then passes back essentially like, oh, here's the success criteria. Here's the basic business analytics that you need on this. Kind of any kind of information about that gets passed into the Cursor agent. And now the Cursor agent gets much more accurate in terms of like what it's generating. So the agents tend to fall apart if you're not clear. So it will try to fill in the blanks between the information that you gave it and what it thinks it needs. So by giving it more information, it has less blanks that it needs to fill in, and then it gets more accurate. And like that's a single example, but these MCP connections work between essentially like all of the tools are publishing these. And so the agents are then able to work with the tools.
I think that's a pretty clear explanation. Now, so that's, and you were referencing before this DB90 methodology. I want to switch gears a little bit because adopting AI agents it's easier said than done. I know a lot of companies are still struggling to make them work. So what do you see as the biggest hurdles teams are facing when they're adopting AI agents? And also, how would you recommend they overcome them?
Yeah, so I see two major hurdles. One is just deciding where you're going to start trying, right? So a lot of these AI initiatives actually fail. The pilot projects fail because the success criteria is too broad. It's essentially like, oh, we're going to give you an agent, and like this agent's going to make you do your job better. And there's no like measurement to that. It's very abstract in terms of like what the agent's actually going to do. It's really up to the user to figure out like how to engage with it. So we've found success when we've been much more specific about like what we want those agents to do, and specifically the problem that we're trying to tackle. So we might look at like, for example, in our situation, the SDLC, we said, oh, we have this very specific problem around getting legacy code bases and understanding what they do. Now we're able to design a system or a series of agents around a very, very specific, discrete problem. And we're able to measure the output of what we're getting to know if we're being successful or not. So that level of specificity has been very helpful for us to determine whether these are helpful or not, essentially, like in the process. The other piece is like the organization piece and like the integration layer. So the agents are very good at doing some things, but not other things. And so somebody still needs to be like an expert operator and understand how to piece all these pieces together. It's like you have a bunch of experts, they're all experts in their own little area, and somebody has to be the manager that pulls the information from one agent and then passes it to another agent. We're moving a little bit into agentic AI, which is sort of the managers, kind of our agents also. But then you still need somebody to like design and program and monitor and determine if those things are working or not. But those are really the two biggest hurdles that I see. And they're not easy problems to solve. Like as we've gone into trying to solve these problems, what we've realized is like the people and the resources required to solve these are actually like expert level operators on these systems. And so while in some ways we get a significant increase in productivity, we also need like very, very skilled people in order to operate these systems in order to get that productivity increase.
Okay, so there's this level of complexity that gets put into the mix. Now, once all of these obstacles are cleared and looking ahead, how do you see AI agents reshaping the space of software development and enterprise operations?
Yeah, so I think we're going to see a significant increase in productivity. It's going to be a combination of what I call like interface and operators. So the interface is really like, how do we actually work with the agents? And what we're seeing now is we're seeing like purpose-built tools come out. And those tools are really just custom interfaces to specific agents. And you can think about Cursor as a good example of this. Copilot, right? It's an IDE and it has an agent behind it. But without the IDE, then the agent's not all that helpful. You're basically ChatGPT without the IDE. And so you really need the IDE and the user interface in order to make that agent like effective. Another good example that we use a lot is Figma and Figma Make. So you still need the IDE that they have or the interface in order to see what the agent's doing and then give the agent direction or not. So I believe we will continue to see like maturity in the tooling market as the tools get better, and the tools will be very specific in terms of like what they're doing. The next piece is the operator. So the agents all have to be supervised by expert operators. At this point, it's kind of like you're driving. The difference between driving a car like down the highway and like driving a race car at 200 miles an hour. If you're driving a race car at 200 miles an hour, you can get into trouble a lot faster. And like that's really what we're seeing with the agents. It's like while it's increasing productivity, it's increasing speed, it's also increasing the pace at which you can get in trouble if you go down the wrong path. For example, like a Cursor agents that we use, like when we're inside a Cursor, sometimes the Cursor agent will try to delete things that it really shouldn't be deleting that will screw up your whole project. So unless you have an expert kind of watching what it's doing, you won't recognize that that's what it's trying to do. And you kind of, now you have a big problem, essentially, that you have to go back and fix. So I do think the interface and the operators are super important, and then connecting all of these things. So I think the silos will mature a lot faster than like the whole integrated process. And that integrated process, it takes reps, it takes times, it takes tool maturity, it takes operator maturity. And, we're very early in this technology cycle. And we're still, as an industry, like figuring these pieces out. And I think you'll see like remarkable progress over the next couple of years, but it's going to be work, and it's going to take people like really digging into this and figuring out the best way to apply the technology.
I like the comparison between driving down the highway versus driving a race car. I'm going to quote you on that. One other thing I wanted to ask you related to this, just to address a lot of people's, their fears, is your thoughts around everybody talking about job replacement or job displacement. I have a feeling I know what you think about this from the answers that you've already given. But looking ahead, what do you think about that argument as well?
Yeah. So when this was first introduced, like we had a large concern around job replacement. We're like, do we even like have anything to do as a company anymore? And what we're finding is like the answer to that question is like, yes, there's definitely still something to do. The experts required to do this are the same experts that were required to do it before. And the value that we see is like the ability to increase our productivity. So we look at this as like, if we can get more productive and we can deliver a better product, cheaper and faster, most likely what is to happen is that there is to be more demand for that product, not less demand for it. And so what I think we'll see is we'll see more tools, we'll see more software, we'll see more startups as people are empowered to do this with less resources, and they can get further down the path without having to have as large of an investment. And then long term, that's great for everybody, right? We see essentially like at a very macro scale, you see the economic output of like the entire country or world is increasing. And that's a great thing for everybody.
Yeah. Okay, good answer. That's what I thought that you were going to say something along those lines. And I agree with you, fully agree with you. Now, as we come to a close, I've got one final question for you. If you had to share a 60-second takeaway message for CIOs, CTOs, other IT decision makers from our conversation today, what would it be and why?
Yeah. So I think at a high level, this technology is transformational. Like you have to embrace it. It's coming. It's a wave. It's the generational technology of our age, basically. So you got to start experimenting with it. It's not obvious where to start all the time. Start experimenting, find use cases like in your organization that are specific and discrete where you think you can add value, and really like go after them. And really there's no substitute for just getting the reps on this. And then lastly, like understand that this is a probabilistic system, right? So some of the work now transfers from being like pure development or build work to like validation work and like really monitoring like what these agents are doing and making sure that it's doing the things that you expect them to do. But if you do that, if you embrace technology, start experimenting, find places in your organization like where you think that this can be helpful and transformational, we've seen great results so far inside of our organization, and I suspect you will as well.
Perfect. Well, you all heard it straight from Ben, so I hope you'll heed that advice. Thank you so much, Ben, for joining us today. I appreciate you coming on, and I really enjoyed the conversation. I know that our listeners will as well.
Thank you for having me. This was great, Christina.
Also, thank you to everyone who tuned in today. We hope you took a lot away from today's podcast. For further information on what we've talked about, please head over to dualbootpartners.com. DUAL boot, BOOT partners.com. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our social media channels at EM360 Tech on X and LinkedIn. And for more great daily content, visit em360tech.com.